Question 1. If we're given the universal set is the odd numbers less than 30, and A is given as 3, 9, 15, 21 and 27, I'll label this as A here, and we'll have this as B. I can see that 15 is in both A and B, so that must be the intersection here. And so B has 5 and 25 in it, and A has 3, 9, 21 and 27. And then I've just got to simply put the others in the outside of A and B because they're not included in A or B, and I would start counting the odd numbers up to 29 and make sure that I don't miss out any. So 1's not in either A and B, so 1, and then we can have 3 has already been given, so is 5, we don't have 7, 9 we do, but no 11, no 13, we have 15, there's no 17, or 19, or 21. Oh yes, sorry, we do have 21 here, so that was a mistake. So we have 23 and 29 left. So that's the completion of the Venn diagram. It says now, a number is chosen at random from the universal set. What is the probability that the number is in the set A union B? Well, what A union B is, it's the union or the whole of A and B put together. So how many numbers do we have? We have 1, 2, 3, 4, 5, 6, 7 numbers out of a total of 1, 2, 3, 4, 5, 6, 7, 8 more outside, so 7 out of 15. So, and that would be fine to leave it as a fraction as a probability, you don't have to decimalize. Question 2. We've got to solve this pair of simultaneous equations, and we've got 3x plus y equals negative 4, and 3x minus 4y equals 6. Well, the first thing we can see is that the coefficients of the x's are the same. So if we just label this as equation A and B, you don't have to do this in the exam, I'm just doing this so I can explain to you. If we times equation B through by negative 1, i.e. times by negative 1 on both sides, this is a nice handy way of doing these when the coefficients are the same. Call this equation C. If we then add equation A and C together, the x parts will vanish, so we'll have no x, we'll have y, and 4y is 5y, and then negative 4 and negative 6 is negative 10. We can divide both sides by 5, and so y is then negative 2. And we can substitute that value back into A, B or C, it doesn't really matter. Let's try and put it into B, so in B, or you can write sub in B for substitute in B, we'd have 3x minus 4 lots of y equals 6, so that would give 3x plus 8 equals 6, and then if we take away 8 from both sides, we'd have 3x equals negative 2, so from here, if we divided both sides by 3, we'd have x is minus 2/3. So we have x is minus 2/3 and y is negative 2. Question 3. The table shows some information about the dress sizes of 25 women. We've got to find the median dress size. So if there's 25 women, then it's like having 12 on one side of the median, 12 on the other. So that's 24, and then it's the one in the middle. So by the time you get to this one, you've counted 12 and one more. So we've got to count to the 13th. So cumulatively we'd have 2, 2 and 9, that's 11 so far. So the 13th woman will be in here, and so the median dress size would be 12. Then 3 of the 25 women have a shoe size of 7. Zoe says that if you choose at random one of the 25 women, the probability that she has either a shoe size of 7, so that would seemingly be 3 in 25, or a dress size of 14, and the dress size of 14 would be 6 in 25. Zoe seems to think that you can add these because she's seen the word or. Well, I'm afraid it wouldn't be 9 out of 25 because having a dress size of 12 would not stop you having a shoe size of 7, which would mean that you could be in both categories. So it's not as simple as just adding them together. So you'd say something about it's not mutually exclusive. Now, to be mutually exclusive means one stops the other from happening, i.e. if you're one of them, you can't be the other, whereas this is not the case. So not mutually exclusive, i.e. a person could be in both categories. Okay, so that stops this sum from being just distinct parts. They could have overlaps, so you wouldn't have captured the whole answer. That's the best way of looking at it. So Zoe's not correct. Okay, let's move on. Question 4. Daniel bakes 420 cakes. It says that 2/7 of them are vanilla. So that's 2/7 of 420. And you can use your calculator, obviously. And that would be 120 are vanilla. Then it says 35% of them are banana. So you obviously, again, use your calculator if you want to. I'm just going to divide the top by 5, the bottom by 5. 20 into 400 is 20 and one more. So 721s or 147, and you get the same on the calculator. So we know there's 120 vanilla, 147 banana. So that's 267 of those type. But what does that leave? Well, again, on the calculator, you can do 420 take away 267, which is 153. And the important thing is here, the ratio of lemon cakes to chocolate cakes is 4:5. So that's 9 parts altogether. 4 and 5 makes 9. And if we do 9s into 153, use your calculator if you wish, that's 17 per part. But there's 4 parts here, so 4 17s. Well, 2 17s are 34, so that'll be 68, will be 4 lots. And you can either take 68 off 153, or you can do 5 times 17, which is 85. And 68 and 85, again, would make 153. So work out the number of lemon cakes that Daniel bakes. Well, lemon cakes would be 68. And we can just write that there. Okay, so if you like using your calculator, then please do, but also practice these types of questions without a calculator. It makes better for your numeracy. Okay? Question 5. In the diagram, AB, BC and CD are 3 sides of a regular polygon P. Show that polygon P is a hexagon, and we've got to show all our working. Well, we're shown here that this is a regular 12-sided polygon, i.e. it'll be a dodecagon, wouldn't it, going all the way around here. So we can try and do some workings out now. So if we had a centre here and we just drew in these arms here, then we know that it's a dodecagon, so it's a 12-sided regular, all the sides are the same, so we're going to do 360 divided by 12, and that's going to be 30 degrees for this angle here. Angles in a triangle, this is isosceles, add up to 180, so these would be 150 between them, so 75 each. What else can we say? Well, we also know, if I just zoom in a little bit more, we also know that this angle would have to be 75, as would this one, because we could just keep doing the same process over and over again. So that would make this angle 150. We know that this angle is 90, so if we had 150 and 90, that's 240, which leaves this angle here to be 120, and they're all in degrees, obviously. So this would be 120 also by symmetry, and I'll just put the degree sign in here. Now you've got to think to yourself, is that making it a hexagon then? Well, if we look at the same method for this problem here, and we just draw the arms in here from the centre, call that X, then we know that if we did the same here, this is a regular polygon, and so if that's 120, then this must be 60, which means that this must be 60, because I could carry on repeating that pattern, which means this is 60, and then we definitely know that because that's 60, only a hexagon having 6 sides would give the whole turn as 360 all the way round. So I do apologise for missing out the degree signs from the angles, but there you go, that's my method. Hopefully when you do yours in the exam, you'll just write yours a little bit more clearly and show all your workings out to support what you've got as your answer. Question 6. The density of apple juice is given, the density of the fruit syrup is given, and so is the density of carbonated water. And it says it gives you the volumes of each of the apple juice, the fruit syrup, and the carbonated water. And what we have to try and work out is that if the volume of the drink that is made is 320 centimetre cubes, then what's the density of the drink? Well, if we look back at what we've already got, we know that there was 1.05 grams per centimetre cube, and we know there was 25 centimetre cubes of the apple juice. So that's just a matter of using our calculator and doing 1.05 times 25. And that, on the calculator, is 1.05 times 25. That gives us 26.25 grams. And then we just do the same for the others. So the first thing that we can do is work out the total mass. And so if we work that out, that's 277.2 plus 21 plus 26.25. And that gives 324.45 grams. So density is what we need to work out. The density is how much mass per volume. That's why if you look at the question here, it gives you a clue to the dimensions. The density of apple juice is 1.05 grams per centimetre cubes. So that's how you can work out density being mass per volume. So we can just put the figures in, and so we work out that density is going to be 324.45 divided by the volume, which is given as 320. So we can do that on the calculator, divide that by 320, and on the calculator I get 1.01390625 grams per centimetre cube, and we want it to 2 decimal places, so 1.01 grams per centimetre cube, and I'll put that as 2 dp. Question 7. Before doing this question, there's an assumption that you know what a sine is, a cosine, and so on. So I'm not going to go into the detail of explaining where they're from. I'm just going to assume you know the basics, and let's have a look at the question. So in this case we have an angle, and we're told it's a right angled triangle, which is good news, and we've got to calculate the length AB. So if you look at this triangle, AB is opposite to the angle and 15 is the hypotenuse. So we know that we're going to be using the sine of the angle because sine is opposite over hypotenuse. So sine 23 will be opposite, which is what we want, AB, over 15. So if we times both sides by 15, then AB, that should be 15 sine 23. So make sure your calculator's in degrees, and let's try this. 15 sine 23, and that gives me 5.860966,927. Always write what's on the calculator display and then look for what it wants. It wants 3 significant figures. So the first, the second, the third, that's going to be 5.86 centimetres, and just write in brackets 3SF. Question 8. A square with sides of length x centimetres is inside a circle. Well, let's try and draw a circle without making a mess. So that will do for there. And then it says the square is inside the circle, so we'll give this a go. It's probably going to look terrible, but let's have a try. And the sides of the square are x centimetres. There's the centre of the circle. And the vertex of the square, each vertex of the square is on the circumference of the circle, so these are the vertices, the singular being vertex. And the area of the circle, so the area of the circle is 49 centimetre squares. Work out the value of x, okay, to 3 significant figures. Well, the area of a circle generally is pi times the radius squared. Okay, so if we started looking at this circle here, we know that's the radius. Okay, so we should be able to work out that. And another thing I've noticed is that this is also r. And is it not true that by Pythagoras, if we look in this right angled triangle here, let's do a different colour. If we look in this right angled triangle here, would it not be true that x squared plus x squared would be this whole length squared here, which is r plus r, which is 2r all squared. So x squared plus x squared is 2x squared, and 2r all squared is 2r times 2r, which is 4r squared. So I think that we can get the radius in terms of x. So if we divide both sides by 4, we'll have 2x squared over 4 equals r squared. So that means x squared over 2 is equal to r squared. So we'll just keep that in mind and see if it becomes useful. It should be, because we know that the area of the circle was given as 49 centimetre squares. So that means from here we can work out what r squared actually is. So we know that 49 is the area, and that's equal to pi times the radius squared. So that means if I divide both sides by pi, r squared is going to be 49 over pi. But we're lucky we had an r squared here. So if I make a little bit more room, then we can say that x squared over 2 equals r squared, which is 49 over pi. If we times both sides by 2, that will give us x squared equals 98 over pi. We want x, which is going to be a positive number, because when you do a square root, there's a positive and a negative. So we want the positive. So x is going to be the square root of 98 divided by pi. So I'm going to try that on my calculator. Just going to give myself a bit more room to write the answer. So we're going to have 98 divided by pi, and then do the square root of that. And what I get is, I get x is 5.585191926, and then three significant figures, 1, 2, 3. So this 5 is going to change this 8 to a 9. So x is going to be 5.59 to three significant figures. And I should really write centimetres here. Okay, so that would be the answer. Question 9. The box plot shows some information about the distribution of the amounts of money spent by some male students on their holidays. What we have to do is first work out the interquartile range for the amounts of money spent by these male students. So let's zoom in a little bit. So looking at the diagram, I can see the smallest amount here, the largest amount, there's the median, this is the lower quartile here, and this is the upper quartile. So the interquartile range is the difference between those two values. So let's have a look at the scale. So 120, 140, 160, 180 and so on. So this one here is at this mark here. So that's quite easy. That must be 150. And the next part of the scale is, this is 320, this is 340, so this would be 330. So the difference between 330 and 150, well, that's 180. So £180 for the first part. And we'll just put the workings out here. So let's have a look at the next part. We've got some information here. We've got the smallest, the largest, the lower quartile, the median and the upper quartile, and we have to put on the grid above, draw a box plot for the information in the table. So I've drawn the diagram here on the same grid. And the last part, part C, says, Chris says, the box plots show that the female students spent more money than the male students. Is Chris correct? Give a reason. Well, the reason I've given is, I said the medians for males, and I have to put these figures down on paper. The medians for male was 250, for females was 300. So yes, Chris was correct because females had a greater median. So as long as you put the figures down that you're trying to use in your reason, then you should be okay. Question 10. Niobe invests £6,000 for 5 years. The investment gets compound interest of X% per annum. At the end of 5 years, the investment is worth £8,029.35. We have to work out the value of X. Well, one way of looking at this is that 6,000 was put in, you had to multiply it by something, and out came £8,029.35. So we can definitely find what that something is by dividing both sides by 6,000. So on the calculator, I'm going to do £8,029.35, divide that by 6,000, and that's going to give me a multiplier of 1.338225. But I know that that is something to the power 5 because the interest rate is applied 5 times. So something to the power 5 is that number. So how do I find the unknown? Well, I just do the fifth root to both sides. So I do that to the power of fifth. Must do the same to that side. So to the power, and you can do it as 1/5 is 0.2, which saves a bit of time. So I use the x to the power button on my calculator, looks like that. And I'll just put in 0.2 where I see that box. So 0.2. And I get 1.059 recurring. Well, that's telling me that it's 1.06. So the interest rate must have been 6% per annum over those 5 years. Question 11. Jeff is choosing a shrub and a rose tree for his garden. At the garden centre, there are 17 different types of shrubs and some rose trees. Jeff says there are 215 different ways to choose one shrub and one rose tree. Could Jeff be correct? You must show how you get your answer. Well, the ways of picking, say, one shrub to start with, well, as there's 17 of them, there'll be 17 ways of picking the shrub first, and then we'd have to see how many different ways for each of those 17 choices of shrub that you could pick a rose, and we have to try and get as close as we can to 215. So one way of looking at this is to say, well, we'd have to multiply these two numbers together to get the total number of combinations. But a quick way is if you look at your calculator and you do 215 divided by 17 to work out this missing amount of rose trees, that would be closest to 215. Well, let's try 215 divided by 17. Well, that means that the closest number of rose trees available would be 12.64705 and so on, which is not a whole number. So Jeff could not be correct. So the answer is a simple no, not correct. Another way of looking at it is to say, well, if you wanted to get a whole number of choices, then the closest you could get is choosing the rose tree. There'd have to be like 12 of them, because then you'd have 17 times 12. But 17 times 12, in terms of total choices, is 204. And then you can't change the 17 because we definitely know there are 17 different types of shrubs. But say you wanted to get a bit closer, you could try, say, 13. So 17 times 13, and that would be 221, which is higher than 215. So you could give that reason as to say why the number of ways of choosing one shrub and one rose tree in total combinations cannot be done in this scenario. So Jeff is incorrect. Question 12. The points A, B, C and D lie in order on a straight line. So I'm just going to put them on there. Not to scale, obviously. It says AB to BD is 1 to 5. And also AC to CD is 7 is to 11. So I think this is a hard question, but I think one logical way of looking at it is to say, if you look at these numbers here, 1 and 5, that represents how many parts to go from A to D. So in this respect, if you look at on that side of the diagram, you can see that there's like 6 parts in total. Whereas on the other side here, to get from A to D, there's 11 and 7, which is 18 parts. So I'll just draw that here. So as it's the same straight line, and it's the same distance from A to D, there seems to be a multiplying factor here of timesing by 3. So one way of looking at this is to say that if it was 1 on this side, it's multiplied by 3, it would be 3 here. But as this is 7 altogether, that only leaves 4 for this part. And then this part is already done for you, it's 11. So my final answer would be AB is 3 parts, to BC, which is 4, to CD, which is 11. And that would be the simplest way of tackling this question. Question 13. We have to write down the 3 inequalities that define the shaded region. Now, in this case, it looks like these points on the extremes are allowed because they're not dotted. So we know we're not just going to have greater than or less than, we're going to have either greater than or equal to or less than or equal to. So let's start with what I think is the easier one, and that is, let's have a look at this line here. Well, it looks to be critical at -2, and we're definitely looking at the y-axis here, so I would say if y is greater than or equal to -2, then that would describe everything above here. So that seems to satisfy one of the regions. Now, the next one we can look at is this line here. Now, it seems that if we go 2 along, we have to go 2 up. So the gradient is 1, and it goes through 0. So that will be y equals 1x plus 0, i.e. y equals mx plus c. The gradient is 1, and it doesn't go through, it does cut the y-axis, but at 0. So that's y equals x, but we seem to want everything above that, don't we? So, and included, don't forget, because it wasn't a dotted line. So we're going to say another condition is y is greater than or equal to x. And then the last condition seems to be to do with this line here. Now, we seem to be able to go along 2 and up half as much. So the gradient will be a half. So y will be a half x plus, and it cuts at 1 there. And it seems to be everything equal to or lower than that. So we're going to have our final one as y is less than or equal to x over 2 plus 1. And then can you see where all the colours meet? We have green, blue and red meeting in this region, so that means that what we've written as inequalities, those 3, must be the correct 3 choices. So that would be the answer for this question. Question 14. We've got to simplify this expression. The numerator is a difference of 2 squares. It has x squared take away 16, which is 4 squared. So we can write that as x plus 4 multiplied by x minus 4. Now, if we are to simplify this expression down, then we're hoping that an x plus 4 or an x minus 4 would appear on the denominator. So let's try and factorise that denominator. So 2x squared minus 5x minus 12. There's many different ways of approaching factorisation of a quadratic, but this is just one of them. The factors of the coefficient of x squared is 2 and 1, because 2 is a prime number, so you can just have 1 times 2. But for 12, you can have 1 and 12, 2 and 6, 3 and 4. So we've got to try and get the number -5, and there's, like I said, many different ways of doing this. So we know we've got a 1x in one of the brackets and a 2x in another. It's under multiplication. We just have to work out where to put the 3 and where to put the 4. Well, one way of knowing which way to put them is to say, can I make the number -5? Well, I can do 3 times 1, or 1 times 3, if I'm reading it from left to right. So I can have 1 times 3, and then I can do 2 times 4. And if I do 1 times 3 take away 2 times 4, that will give me 3 minus 8, which is -5, which is what's required here. Like I said, this is just one way of doing it. So what did I do? I did the 1 times by a 3. So I did an 1x multiplied by a 3. So that would put the 3 in here, because that's the only way this x can be multiplied by the 3. And that leaves the 4 to go here. So I can start multiplying out. So I get the 2x squared, which is what I wanted. But I've got to say to myself, how do I get a -12? Well, I could try putting the -4 here and see if that works. And that would give me this, but would it give me -5x for these ones here when I add these ones together? Well, this would give me -8x, and this would give me 3x, which is exactly what I wanted. And then you can relate that to this method of doing it here. With this method, I just say to myself, okay, here's my 2 brackets. I have an x that goes with a 3 positively, and I have a 2x that goes with a 4 negatively. So that's another way of looking at it. So either way, have a bit of research on the internet about how to factorise if you're not sure, and then go from there. So yes, there was an x minus 4 in the denominator, which is good, and there's a 2x plus 3 here. So these would cancel out because x minus 4 divided by x minus 4 is just 1. So the required answer would be x plus 4 all over 2x plus 3. For part B, we've got to make v the subject of this formula. So we have w is 15 lots of t minus 2v all over v. So the way of getting v as the subject is to try and get the v's as multiples on the same side. Now, they seem to be on the same side already, but if you just have a look at what I'm going to do, this will make some sense to you. Let's multiply both sides by v. Well, then we're going to have wv equals 15 lots of t minus 2v. Because when we times both sides by v, then this one cancelled out and we were left with wv, or vw, is 15 lots of t minus 2v. Now we're going to multiply out this bracket, and that will give us 15t minus 30v. And then here's what I said, try and get the v's on one of the sides only, and try and get them so you can factorise them out. So if we add 30v to both sides, then we're going to be left with that. Now, here is always the way of doing this. We can now factor the v out. And then, because this is a multiplicative, it's under multiplication, we can divide both sides by this number, which is w plus 30. So v will be 15t all over a denominator of w plus 30. Question 15. You should try and remember that the area of a triangle in this case is a half AB sine C. But if that doesn't make any sense to you, then just drop your own perpendicular in, call it H. There's your right angle triangle here, we'll label it 1. And then you can say to yourself, okay, I've got an opposite, I've got a hypotenuse, So that must mean that sine 45 is opposite over hypotenuse. So therefore h must be x plus 3. Now put a bracket around it because it's all times by sine 45. And then you know the area of a triangle. That's a half times the base times the perpendicular height. I'll call that h subscript p. So that's a half times the base, which in this case is 2x minus 1, times the perpendicular height, which we've got here. So, of course, we could have got the same using the formula, but if you're not very good on remembering formulae, then just do it from first principles. It won't take you very long. Now, sine 45 is root 2 over 2. You're supposed to know those. And let's just get this in here. We can make it a little bit more concise in a minute. It says the area of the triangle is 6 root 2 meter squares. So let's have a look. I don't think this is going to take too much work. So we know that 6 root 2 is equal to root 2 over 4, lots of 2x minus 1, lots of x plus 3. Let's see if anything cancels. Yep. We can times both sides by 4, so that will give us 24 equals, and then we can multiply this out, 2x squared plus 6x minus x minus 3. Let's give ourselves a bit more room. And we'll take that up here. So I'll just write this out again. So 2x squared, I'll just put those together, collect those terms, so that's 5x minus 3. Let's get everything on the right hand side, so take 24 from both sides. And then let's have a look at factorising. Let's go back to the question to see what it says. I'm sure it wants x. Yep, calculate the value of x to 3 significant figures. So if it's 3 significant figures, that should be telling you something. You should be realising that it's probably not going to factorise. I can tell you why I don't think it will, because if you do b squared minus 4ac, you know, the bit that's under the square root sign in the formula. So if you do b squared, you're going to get 25 minus 4 times a, which is 2, times negative 27. That's going to give you 25 plus 8 times 27. And if you do that on the calculator, that's not going to be a square number, I don't think. Times 8 plus 25. That's 241, which is not a square number. So we're going to have to use the formula or complete in the square. I suggest you just go straight to the formula. It'll probably be the quickest way. So x is going to be minus b plus or minus the square root of b squared minus 4ac, well luckily we've already got the b squared minus 4ac, over 2a, 2 times 2, this is the a part, because don't forget it's a x squared plus bx plus c we're looking for, and that's where it comes from when we solve that equal to 0. So minus b plus or minus the square root of b squared minus 4ac all over 2a. So x is going to be a positive value, it's not going to be the negative, so we're not going to look at negative 5 minus, we're going to look at negative 5 plus. So we're going to have negative 5 plus the square root of 241 all over 4. So the square root of 241 I've already done on my calculator. I'm just going to take the 5 off, which is the same as doing negative 5 plus what the value was. And that's 10.5241747. And then I'm going to divide everything by 4. And that gives me 2.631043674. I think it wanted it to 3 significant figures. Yep. So let's have a look. Always write down what's on your calculator display. So that's nice and simple. That's 2.631043674. 2.63, and I think it was in meters, wasn't it? Meter squares, so I'm going to say 2.63 meters to 3 significant figures. Question 16. Well, we have an iterative form here, and if we want to use our first value as negative 2.5, that is our x subscript 0, that's when n equals 0. So if n was set to 0 in here, we'd have our first value would be negative 2 minus 4 over negative 2.5, and don't forget, all squared. And you'd put that in the calculator and you would get your answer. An alternative way is to say, and I'll put this a different colour, if you type in negative 2.5 on your calculator and then press the equals button, that value will be stored in as the previous answer. And there is an A and S button on your calculator. Then all you have to do to find the first value, given that negative 2.5 is put in, you just have to type this into your calculator. And that will give you the value straight away. So let's try that. So I'm typing negative, not minus, but negative 2.5, just pressing equals. Right, that's stored in my calculator. Now I'm going to do negative 2 minus 4 divided by A and S squared. And on my calculator, that gives me negative 2.64. Now, the nice thing about this is that is then stored as my next answer, which then will go in to give my next value. So the long way would be to say, okay, let's make a bit of room here. The long way would be to say, well, x2 is minus 2 minus 4 over, now we put negative 2.64 in, but all you have to do with my method is you just have to press the equals button again and it will automatically put in the next value for you, and I get negative 2.573921028 and so on, and then I press equals again and I will get negative 2.6037672255. If you're doing it the slower method, then you must put this down as your second value, as your third value, into this iterative formula in full. You can't just round it, say, to negative 2.57, because that will give you an inaccurate value for the next value. So try the ANS method if you can and see what you get. It doesn't say in part A to give the values to any degree of accuracy, so we're just going to leave those there. Now it asks you to explain the relationship between the values of x1, x2 and x3 and the equation that we have here. So let's see. Well, we know from part A that we were able to get closer and closer, well, not necessarily closer and closer, but we did 1, 2, 3 iterations and we got to around negative 2.6 to 1 decimal place. Okay, but what did that mean? Well, if we look at this part here, x cubed plus 2x squared plus 4 equals 0, and then compare it to our iterative form, we would have x equals negative 2 minus 4 over x squared. I've taken out the m plus 1 and the n here because that's not necessary to have a look at the actual form of the equation. We're not trying to iterate here, putting numbers in. I want to see the relationship between these two forms. Can I, for example, get from here to here? Well, if I can, then I can say that x1, x2 and x3 are approximations to a root of that cubic, okay, namely x cubed plus 2x squared plus 4. So I think the first thing we can do is I can see that if we took away the 4 from both sides first, we'd have x cubed plus 2x squared equals negative 4. Then if we took 2x squared from both sides, we would have x cubed equals minus 2x squared minus 4. And then if we divided both sides by x squared, we would end up with x equals minus 2 minus 4 over x squared. And yes, that means I can get this form to match the iterative form of part A here. Okay, so that's what I would actually do. I'll write the explanation in quickly for you. And I skip forward a little bit so you can see it without me writing it all out. So there we go. So just have a read of that. And it's basically about having this linked to this here. Okay, so give those a good practice and make your own rearrangements and see whether you can find any other roots for cubics and quartics, for example, of your choice. Question 17. A train travelled along a track in 110 minutes, correct to the nearest 5 minutes. So the way I do this is I take the 110, I look at what it's nearest to, the nearest 5 minutes, and I cut that in half, and so I'd have 2.5 either way. So I would say that 110 could be as low as 107.5 or as high as 112.5, although it can't actually be 112.5. You can also get away with saying 112.49 recurring. Now if we look at the track, and we'll put minutes here, if we look at the track, that's 270 kilometres long, and it's measured to the nearest 10. So I'm going to take my 10, I'm going to halve it. So I'm going to go down by 5 one way, so that's 265, and as high as 275, or you could say 274.9 recurring kilometres. Now, could the average speed of the train have been greater than 160 kilometres per hour? So the average speed, and it's kilometres per hour, so it's kilometres on top and hours underneath. So we want that to be the largest possible. So it would be a good idea to have the kilometres being the biggest. So I'll put 275 on there. If you try to put 274.9 recurring in your calculator, obviously you can't do that because you'd be there forever. So 275 is as good as, because the calculator will just round it to that anyway. And if you want the biggest, so you want the highest number on top and you want the smallest number on the bottom. I always think it as cakes shared between people. If you want the largest amount of cake, you want the most cake to start with and the fewest amount of people showing up. So we want the lowest, the denominator to be, now that's in hours, so I'm going to have to convert that into hours. So what that would give me here is 60 minutes, which is 1 hour, and then I've got 47.5 minutes left, and I want to do that as a fraction of 60 minutes, so 47.5 divided by 60, that gives me 1.7916 recurring. So all I've got to do is that sum now, so I'm going to do 275 divided by 1.791 and then quite a few sixes and then stop, and I get 153.4883721, and that's kilometres per hour, and that is not going to break the 160 kilometres per hour barrier, so no, it couldn't. Okay, so that's that first part done. For the next part, it says Jake's assumption was wrong. The track was measured correct to the nearest 5 kilometres. Explain how this could affect your decision in part A. Well, let's have a look. We had 275 over, let's have a quick check what it was. 1.7916 recurring. So 1.7916 recurring. And if this number was not now what we needed, we wanted to take the 270 and it was to the nearest 5 kilometres, don't forget. So we'd have to take that, split it in half. So if we wanted the maximum amount now, it would be 272.5. This still stays the same, the time. So that would mean there would be less. I'll write this out as a statement. There would be less distance in the same time. So the maximum average speed would drop. Okay, so quite a long statement there, but I think necessary to write that down. Okay, so let's move on. Question 18. A, B and C are points on a circle of radius 5 centimetres, centre O. DA and DC are tangents to the circle, and DO is 9 centimetres. Work out the length of arc ABC. So we want the major arc here going from A through to B through to C. So it seems to me that these are obviously right angles, and you can write that reason down. Okay, so we can write that reason down here, that angle OAD equals 90 degrees because radius and tangent meet at 90 degrees, or the angle between a radius and tangent is 90, something along that nature. Make sure you state that. It's one of the circle theorems. And then to get really into it really quickly, we can say, right, if we find this angle here, we'll call that angle X. If we double it, that will give us angle Y. And then if we take Y from 360, we'll get the angle we want here, and we can call that theta. Once we've got theta, we know that the length of the arc, the major arc, ABC, would be that fraction of 360 degrees. Now we know what the circumference of the whole circle would be. That would be pi times the diameter, the radius being 5, the diameter is then 10. So we know that it's this fraction of the entire circumference that we're looking out for. So we can just do some simple trigonometry, I think, to work this out. So the first thing I'm going to look at is, we know that when we've got this angle X, this would be the opposite. And then this would be the adjacent here. And then this would be the hypotenuse. So we know that cos X is going to be adjacent over hypotenuse. So X is going to be arc cos, or the inverse operation to cos, so cos minus 1 of 5/9. And we can do that on our calculator. Make sure you calculate it in degrees, of course. So shift cos 5 divided by 9. And that gives me 56.2510114 degrees. That's for X. So Y will be double that. And that's going to be 112.5020228 degrees. So we now know what theta is. Theta is going to be 360 minus Y. So that's going to be 247.4979772 degrees, and I just have to then put that into here. So I'm going to divide that by 360 and then times it by 10 pi. And my answer would be, on my calculator, I'll just create a bit more room here. So the answer that I get on my calculator is 21.59827,297, and that's going to be in centimetres, and I want it to 3 significant figures, so this 9 will change as 5 to a 6, so I'll have 21.6 centimetres to 3 significant figures, 3SF. Question 19. We have an inequality to solve here. So we're going to look at this expression first and see whether we can factorise it. And one good way is to do the discriminant test, b squared minus 4ac. So if we have this is a, b and c, then b squared is 9 minus 4 times a, which is 2, times c, which is negative 2, which gives us a positive. And we've got 4 times 2 is 8, times 2 is 16, and 9 and 16 makes a nice square number, which means that in your formula, which you should be used to by now, that helps you find the values of x. If this number here, the discriminant, it's called, I'll write that for you, if I can spell it, that is. So discriminant. So the discriminant, if that's a nice perfect square number, then this square root sign can undo that square number and make it a whole number. And then you're going to have a nice easy number for x, which means it can be factorised simply. So 2x squared plus 3x minus 2 is greater than 0. Well, let's have a look. Well, we can see here that we have 2, so that can be 1 and 2, 1 and 2, and I have to get the number 3. So if I put a 2x in here, I'd have to have an x in here. And if I put a 2 here and a 1 here, that would give me a 4x, and this would give me an x. But I want to have a positive 3x left when I've done all my multiplying out. So I'm going to make this a positive, because then I'll have 2x times 2, which is 4x. And if I make this one a negative, that means I take 1x off, and that gives me the 3x. And then most importantly, the negative times the positive gives me the negative here, which is important. So it looks to me that all we have to now look at carefully is this part here. 2x minus 1 times x plus 2 is always greater than 0. Now, I've taught this type of question a great deal at A level, and what I usually tell my students is, look at the shape of that quadratic. It's going to be of this type of shape. You haven't got to get it, to scale or anything. It's not going to have this type of shape because this number here is positive. So what you have to then do is draw a line representing the x-axis for your solutions. Put these brackets equal to 0. So this one would give x is a half, and this one would give negative 2. Put these in size order on your number line, and then just do what it says. It says, where is this expression, which is this quadratic shape? Where is that shape greater than 0? Well, everywhere here where x is greater than a half, and everywhere here. The axis would go on forever. Everywhere here where x is less than negative 2. So these would be the criteria here to fulfill the question, and that's how we can do quadratic inequalities. It's actually quite straightforward if you look at the shape of the graph and draw the x-axis on there. Question 20. The equation of a curve is y equals a to the x, and a is the point where the curve intersects the y-axis. So when you're on the y-axis, so anywhere along here, your value for x is 0. So that would mean that our y value would be a to the power 0, and a base to the power 0 is 1, so y would be 1. So when x is 0, y is 1, and that would be the coordinates of A. The equation of circle C is x squared plus y squared equals 16. So if you know the general equation of a circle, centred at the origin that is x squared plus y squared equals r squared. So the centre here is 0, 0, and the radius is not r squared, it's just r. So here we have a circle centred at 0, 0, and the radius is 4 in this instance because it's 4 squared. The circle C is translated by the vector 3, 0, so a long 3 on the x, no change on the y. So we have to basically sketch circle B. Okay, so C is translated and we have to now sketch circle B. So if the vector is 3, 0, then if the centre's at 0, 0, the x goes up by 3 and the y doesn't change, so the centre will be 3, 0 and the radius is unchanged at 4. So we can now do a little sketch here. So I've done a little bit more than a sketch for you. I've imported a graph. So the red circle here, this is C, and the blue circle, this is the one that's been translated by the vector 3, 0, and that's B. Okay, so you'd obviously try and do your best to try and show at least where the centre is. I think if we were doing this in the exam, the centre would be 3, so you'd write that down here, and you'd have this as your centre, and then maybe you might just still show that that's 4 units, okay, something like that. Make sure that you read the question through and notice here that it says any points of intersection with the x-axis as well. So here you'd write -1, 0, and here you would write 7, 0. I may as well write 3, 0 here as well to show the centre. Okay, so that's that question sorted out.